Alright, what's up everybody, and welcome back to our next video in our series of how to go from zero to hero in Cadence development. And in this video, we're going to be talking a lot about how to send a transaction on a backend. So what do I mean by this? Well, in previous videos, I showed over how I went over how to log in on a client side, how to log in with Blocto, and then send a transaction with Blocto. Now the thing there is that, you're sort of sending transactions with your Blocto account and it's sort of handled for you on the client side, which is really great because Blocto does a great job doing that for you. But there's sometimes where you want to send a transaction on a backend, and maybe this is because you have some server admin, or you have, a private key and you just want to send a transaction without having to deal with all the Blocto stuff. So in this video, that's what we're going to be talking about, is how to send a transaction on a backend where you need the private key and like a key ID, which we'll go over in the video and what that all means. So with that being said, let's go ahead and get started on this example. So what I've done so far is I've opened up a terminal that I just have an empty folder called send transaction, and all that has is nothing inside of it. So let's go ahead and make our flow.json file by doing flow init, and that's going to create this flow.json file right here for us, which is super cool. So what I'm going to do now is just make a testnet account. So I've done this before in previous videos, but let's just go over it again. Because I think it'll be helpful for this video to have our own new private key and all that. So this is also all going to be on testnet, so disclaimer. Okay, so let's do flow keys generate. So this is the process of creating a new account on testnet. Flow keys generate, and we're going to do -- network equals testnet. And then you don't have to do this, but I like to specify the signature algorithm to be ECDSA underscore SECP256K1. So there's either this option, or there's ECDSA, I think it's P256, and that will be the default one, but I like to specify this one because I usually do it this way, so it makes more sense for me. Okay, so here's our private key and our public key. So what we're going to do first, actually, is we're going to take our public key, we're going to copy and paste the public key, or we're going to copy it, then we're going to go to a web browser, and let me actually just bring this web browser over here, and you're going to look up a flow, I think it's called flow faucet or something. Yeah, so of course you're gonna get a bunch of pictures of a faucet here, but if you click on this one, flow testnet account, create account, you can go to this page and then type in your public key. So I'm gonna paste my public key, and then down here I'm gonna change the signature algorithm to SECP. Now if you didn't specify that here and you just left this blank, or it's the other one, then make sure you leave it at the P256, okay? And then don't touch the hash algorithm. And then we're gonna say I am human. Let's make sure we're human and click all the boats. I don't even know if I'm clicking the right ones, but let's just verify. Cool. And then click create account. Now, if testnet's healthy, this should go through, and it should be all fine to go. And I'm hoping it does so that we can go on with the rest of this video. So it should take a second here. And what this is doing is, so this is taking your public key and it's actually creating a new account for you. So it's going to give you like an address that we can use in a bit. So boom, this is our address. Awesome. And it's giving us 1,000 flow testnet tokens on testnet, which is great. So what we can do is we can actually, if we want to view this on the testnet, we can copy and paste this address and go to the flow view source /testnet/account and copy and paste our address, and boom, this is our account now. So you see there's one key in it with the algorithm that I used. This is my public key ID 0. That'll be important in a bit, and all this cool stuff, right? Okay, cool. So let's go back to our code here, and what we're gonna do is we're gonna set up our testnet account. So the way you do that, I'm actually going to copy and paste some stuff here because it gets a little confusing, but I'm going to explain all of it, so don't worry if you don't get it off the bat. Okay, so what this is doing, let me actually format this a little better. Okay, so in flow.json we're going to specify that we have a testnet account. Now let me go ahead and in here, you put two things. You put your address and your key. Now the address I'm going to say is let's go get our thing here. So actually, wait, I don't even think we need to do this. So never mind. Now that I'm thinking about it, I don't think we need to do this actually at all. So let's go ahead and not do that. Actually, no, I think we do need this. Okay, yeah, so we do need this. We're going to take our address on the front end, and we're going to copy and paste it into the testnet account here, just like so. All right, cool. Now in here we have the key. We're gonna leave hex, leave 0, signature algorithm. Let's put this one here. If you use the other one, make sure to put that one instead. So ECDSA P256, I believe. This one right here, and then our private key. So let's go and get our private key again from our terminal here that we made. So let's take our private key, and let's put this inside the flow.json like so. Now, this is a fake private key. I just generated it, so if you think you're gonna get a bunch of money, you're not, I promise. Okay, awesome. So now that we have that, let's go ahead and make a new file here called main.js, and we're gonna just do some sample stuff in here. Now, one other thing I'm gonna do is I'm going to npm init, and so this is gonna create a package.json for us so that we can start doing some stuff. Now, this is just a lot of setup, so you don't really have to do this part if you already have a backend going, but I'm just doing everything from scratch so that it makes more sense for people. Okay, cool. Now, what we're also going to do is we're going to npm install @onflow/fcl and @onflow/types. And then two other things that we're going to install are, let me just make sure I get this right. We're going to install elliptic, and we're also going to install SHA-3. So make sure that you do all four of those. Onflow/fcl and onflow/types you've seen before. This is just so we can send transactions. And elliptic and SHA-3 are so that we can actually sign our transaction on the back end. So instead of having to do that through Blocto or FCL or whatever it may be. Awesome. So now we sort of have a file going here. And what we can do first is just import both the FCL and type. So let's const FCL equals require @onflow/fcl. It already knows it. And we can also do type. So const t equals require @onflow/types. Boom. All right, so that is awesome. Now, one more thing we're going to do is we're going to set up basically our function for like actually executing the transaction. Let's go ahead and say const, let's just say send transaction is going to be a function like so. And in here, we're going to actually like basically send a transaction. So let's go ahead and say const transaction ID equals await fcl.send. And now, I'm sure many of you have seen this sort of thing before if you've watched the front end videos. This is all sort of the same thing. So we're going to fcl.send. Now in here, we're going to do fcl.transaction. And we're just going to make a pretty simple transaction because that's not really the point of this video. It's just to see that it actually worked. Let's do fcl.transaction. Let's just initialize our transaction here like so. Let's do a little prepare statement with the signer is the auth account. Boom. Like that, and then we'll just say that we'll just have an execute here as well. That's not really going to do anything, right? So it's very simple, okay? All right. Now we're going to add some arguments here. So let's just, I don't know, let's just add some fun arguments so that we can see it when we view it on FlowScan. So let's just add two arguments. Maybe we'll add one argument that's like, I don't know, like account. I don't know, let's just do like a number. So like number will be an int, and a greeting will be a string, something like that. So inside of here, we'll do fcl.arg. And we'll type in like, I don't know, 1, and that's a t.int. And then our second argument will be fcl.arg hello, and this will be a t.string, so simple enough. And then this is where things get a little interesting. So now, you know, if you remember from the previous videos, we need fcl.proposer, right? We also need fcl.payer, and we also need fcl.authorizations, right? And then here's where you pass an array of authorizations that would basically go here. So in this case, it's only one. And then we can specify fcl.limit, and then this is just like the gas limit, so it can be whatever we want. And then we'll then fcl.decode, and we can, you know, console.log the transaction ID and call it a day. So console.log transaction ID like that. And we can make this function async like so. And then, you know, what we can do is just test, call test down. I think it's called send transaction. So we'll call send transaction down here, and that's all good to go. Now, what we can also do is just add a console.log saying sending transaction to make sure that it all works. Okay. Now, right now, this is where things get interesting, because if we were on sort of like a React front end where we were logged in with Blocto, for example, what you could do is you could, in here, you would say fcl.auths, right? And this would be basically your Blocto account that you're signed in with. But, you know, and you would type that in for both the proposer, the payer, and the authorizations. But in this case, we need what's called an authorization function. So on your front end, where you would type fcl.auths, this is actually an authorization function that it already has your private key, your key IDs all there to do it for you. But in this case, we're going to need our own authorization function. And so that's what we're going to sort of define together. So right now, this isn't anything, but we're going to do that together. All right. Cool. So the next thing that we're going to do is we're going to make sure that we configure FCL to point to TestNet. So you can do that by saying fcl.config put the access node API to testnet right here. And remember, we don't have to specify a wallet or anything for Blocto because we're not using Blocto. So I know I keep repeating very simple stuff, but I think it helps to sort of see. Okay. Now, what we're going to do is we're going to create another folder called like helpers. And so inside this folder, we're going to do authorization.js. So inside here is where we're going to do all of our authorization stuff, which is where things get sort of interesting here. So let's go ahead and import FCL again. So it equals require it, I guess. So require @onFlow /FCL like that. And then we're going to need to include some other things. So this is where I'm also going to take some code and put it in here. So what this is this is SHA-3. So keep in mind that while I am giving you a tutorial here, I barely know what a lot of this means. I just know that it works, and I think that's why you're here anyway, so that's fine. But let's go ahead and just do this, right? So SHA-3 is what we're going to use to sort of like, I believe it's just to like sign our thingy or, create some sort of hash. But again, I'm not entirely sure, but let's just put it there. And now it's also require elliptic. So these are the two things that we installed, SHA-3 elliptic. And then you're going to do var EC and then const EC equals a new EC that is secp256k1. Now, in here, if we scroll up a little bit, if you had not done the SIG algorithm here and you just left it blank, or you're using ECDSA P256, then inside of here, you would put P256, okay? So either one, but I'm using sec P whatever. So that's how I'm going to sign my thingy. But make sure that you put the right one here, or else it's not going to work. Okay. Now, what we're also going to do is say const address, like that, equals this. And so our address in this case, we can actually go back to our flow.json because we stored it here. Here's our address. So let's go back and put our address like that. And we can also say const private key. I'm going to make both of these like this. Equals. And our private key, we also put right here. We put our private key here. So let's take that. Go back to authorization and paste that in. Awesome. And now this is where we're going to start implementing our functions or our authorization function. Okay. So we're going to say const authorization function equals async. It's going to take in an account, and there's going to be an arrow here. And what we're going to do is we're going to export this function. So module.exports equals, and inside here, we're going to put authorization function like so. Now, things get a little complicated in here, so I'm going to write all of this out. But we're going to return an object, and this is going to return the account. And by the way, like I said before, just know that this works. I have been doing this many times, and I still don't fully know how it works. But to be honest, I don't think that's entirely the point anyway. And if it works, then it's good. But this is just what it is. So, and then we're going to put E like that. Oh, oops. I did not mean to put that there. Like this, okay? And I've also forgot to say that our key ID up here is going to be 0, and I'm going to explain this in a bit and why it actually is 0. Okay, so like that. Actually, you know what? I'll go ahead and explain it now. So what a key ID is every account on Flow can have multiple keys. So when we run the view source here, and I was showing you all these keys here, you can see that I only have one key and it has a key ID of 0. So this is the key that you're going to be sort of signing with. And in this case, because I only have one key and that ID is 0, we have to use 0 here. However, certain accounts have a lot of different keys, and as long as the total key weight is 1,000, the transaction will go through. So in this case, my default key already has 1,000, so I only have to use one key here, and that's usually the case for these sort of authorization functions. But I just want to note that if you have a bunch of keys here and you have another key that has weight 1,000, you can also use that key as well. It doesn't have to be 0. So just that you know that. And in the next video, we're actually going to go over how to add public keys to an account so that you can sort of send multiple transactions at a time. Because when you send a transaction, you can only send one transaction at a time with each key ID. So if I send a transaction with key ID 0 and then right away send another one with key ID 0, it's not going to work. It's going to say invalid sequence number, whatever, which is this number right here. That's sort of how Flow makes sure that you're only sending one at a time. So in the next video, we're going to go over how to have multiple keys, and so you can send multiple at a time, but that's sort of beside the point for now. Okay. Now, so we put the temp ID, and now we're going to put ADDR, and this is going to be fcl.sans prefix, and we're going to put an address here. Now, I know this is probably boring to watch, but I want to type this out so that it's harder for everyone to make a mistake when you're watching this. Because I think it's easier if you follow along every step of the way. So we have a temp ID, an address, a key ID, and the last thing we're going to do is put in a signing function. And this is going to be an async signable arrow like that. And in here, we're going to return another thing that's going to be address fcl.with prefix. And we're going to type in address again like that. Then we're going to say key ID is going to be a number which is 0. Oh, and I should put just key ID in here so that you can change it later. So key ID like that, so that you can replace this address, private key, and key ID with whatever you want. And the last thing here is going to be signature. Signature is going to be sign function, signable.message. Now, the one thing we haven't done here is we haven't implemented the sign function, so we have to do that together right now. Okay. So in order to do that, let's go ahead and make a sign function. So the sign function is going to be up here, and this is going to be const sign equals, it's going to take in a message, like so. And this message is the signable.message right here that we're going to be signing. So inside here, we're going to say const, and actually, you know what? It might make sense for me to just copy this because this is like just disgustingly complicated in a way. But I'm going to walk through this together. So here's our sign function. We have a key, and let's make sure to change this to private key. So we have a key here. So it's going to say EC, which is this variable we defined up here. Dot key from private buffer.from. We're going to pass in our private key here and hex. And then it's going to do all this stuff as well, right? So it's going to do const sig equals sign, n equals 32, rs, whatever all this is, right? So this is our sign function. Cool. Now, one more thing we have to define, and then we'll almost be done, is this hash function right here. So right here where it says hash, we haven't defined this either. So we have to define one more function called hash, and this is going to take in a message, like so. And this is going to say const sha equals new sha3 256, like so. And then sha.update buffer.from message and hex, like that. And we can add our little semicolon here. Oh, oops. And then the last thing here is return sha.digest, and that is about it. So this is all we should need in order to get this to work, right? So I'm hoping that this is going to work and that we're all going to be good. So again, this is our authorization function that we're going to export here. And then inside of our main.js, we're going to require it. So let's go ahead and in our main file over here, say const authorization function equals require from /helpers/authorization.js. All right. And then that authorization function gets passed in here, here, and here, and we should be good to go. So inside our terminal here, I'm going to, I think it's down here, right? So I'm going to say node main.js, and that's going to run our main.js file. And it says sending transaction. And then it gave us the transaction ID. So let's go ahead and paste this. Let's go ahead and copy this transaction ID. Go to testnet.flowscan.org and paste our transaction ID here and click explore. And boom, it went through. So we signed a transaction on the back end, right? So here is our script. We have the arguments here. Here's our two arguments. The int was 1 and the string was hello, and we should be good to go, right? So I actually was at the beginning of the video. I don't know why I had us do this, but I personally believe it's like helpful to sort of keep track of all our accounts in the flow.json file, but you don't have to do this. In case you want to create more accounts or whatever, for example, if you want to, create an account in the terminal instead of like in the flow testnet faucet that I was showing, you can do it if you have the account in here, but you don't have to do this actually. In fact, if we deleted this, let's go ahead and delete this. You see, we could still run the main.js. So if I were to do this again, node main.js, it'll send us a transaction. We can go ahead and take this to FlowScan. Let's go ahead and do that now. And you should see that it goes through just fine. And look, it even says that, look, the proposer, the payer, the authorizations, these are all 0x0c, which is what we had in our account, right? So that is our account that we had here. But again, you don't need that here. I think it's helpful to keep track of it, but you definitely don't need that. So that is how to send a transaction. In the next video, we're going to talk about how to add public keys to an account, so that what you can do is in the proposer, you can propose with different key IDs. So Where that gets really helpful is, for example, you know, I should be leaving this to the next video, but like I said, if we tried to run these really quick, actually, you know what? Why don't we go ahead and this is gonna seem weird, but let's just go ahead and do that. So let's send a bunch really quickly. Let's see what happens. And I'm sure there's something weird is gonna happen. So let's take this transaction and go to the testnet, like here. Look, here it is. And well, you could sort of see that error for a second. I don't know how it ended up going through. Okay, well, there it is. So public key 0 on account has sequence number 3, but given 2. So the reason it's saying that is because we tried to send transactions way too quickly. And what's happening is on the view source, you'll see the sequence number is 3s. And what it does is every time you use the key, it increments 1. But if multiple get sent at one time, it doesn't know what's going on, so it panics. But in the next video, we'll talk about how to add multiple keys to an account so that you can run transactions really quick on your backend. So I hope that was helpful to everybody. And if it was, then, you know, like, subscribe, or comment. And I'll see you in the next video. So thanks. Bye.